Hi students, welcome back. Coming to the next topic, that is a page replacement algorithms. So the page replacement algorithms use it to, we have to, which frame it has to be replaced and which replacement algorithm shows the lowest page fault rates. So that will be decided with the help of this page replacement algorithms. So actually this page replacement algorithm decides which memory page to page will be swapped out when a page of memory needs to be allocated. So there are three techniques that we use, three different algorithms that we use in the page replacement algorithm. One is FIFO, first in first out algorithm, and then least recently used algorithm, LRU, and the optimal. So these are the three page replacements algorithms. Why we are using this three different algorithms? Because with the help of these three different algorithms, we can find out which replacement algorithms occurs the less page faults, less errors like that. Okay, so hit ratios and miss ratios can be calculated based on that values. We can select the best algorithm. So the page, these are the three different page replacement algorithms. Now let us see the first page replacement algorithm, that is the first in first out. First in first out page replacement algorithm. So the name itself is saying that it is the first in first out. So whatever the first we are enter into the page, that page has to be deleted first. So it is very easy to implement. The FIFO page replacement algorithm selects the pages for replacement that has been in memory for longest time. So replace the pages, that has been in memory the longest time. So a new page must be loaded. The page recently bought, it is written. Let me explain with simple example. Let us consider an example how this first in first out page replacement algorithm will work. So let me explain the FIFO example. Now I am taking some reference string. So reference string I am taking here is 7 0 1 2 0 3 0 4 2 3 0 3 1 2 0. So these are the pages that are present in the process. Let us take this is a string. These are the page numbers, pages that the CPU is demanding. The CPU is demanding for these pages. Let us take the P1 process. So this P1 process consisting of pages. So these are the pages that are present in the main memory. So the main memory at a time can't store all these pages because the main memory size is less when compared to the logical memory. Now the CPU is demanding the page numbers. So based on the page, whenever the CPU is demanding the page, it has to check that page is present in the main memory or not. If it is not present in the main memory, it has to get from the secondary memory and store it in the main memory. So that is a page replacement concept. So here while it is, if the page is not found in main memory, then we call it as a page fault. So that we already know. Whatever the CPU is demanding for the page, if that page is not present in the main memory, that we call it as a page fault. So whenever the page fault is occurred, we have to bring that reference page. So these are all the reference pages the CPU is demanding. So these reference pages are nothing but the process P1 holds these reference pages. So it has to bring that reference page which is demanded by the CPU from disk. So every time getting that from the disk is when compared to this is if the page faults are more, then the CPU time is wasting. So because the disk is slow when compared to the main memory. So every time if the page fault is occur, you call it as a page fault. there is already the page is present, if there, that you call it as a page hit. So some terms you came across in this while you are discussing about this algorithm, that is a page fault and page hit. So page hit means whatever the page that is demanding by the CPU, if that page is present in the main memory, that you call it as a page hit. If the page is not present in the main memory, that you call it as a page fault. So let me explain that. So let us take the main memory is holding only 3 frames at a time, only 3 pages at a time, not at a time. So that is only the main memory capacity I am talking about. So this is the main memory. Here it is having the frames, frame 1, frame 2 and the frame 3. So don't be confused, see it clear. So this is a frame, this is the main memory. So the main memory can hold only the 3 pages, only it can hold 3 pages. Okay. So if you want to store another page, it has to be replaced. How it is replaced? By following the concept first in, first out. Okay. So starting, the main memory is always free. So whenever you are starting the system or the main memory, that is a RAM, is free. So means now the CPU is demanding for, first it is demanding for 7th page. So it checks in the main memory. The CPU is demanding the reference string, that is page 7, that it is not present in the main memory. Okay, first it is free. So 7 is not here. So whenever the 7 is not here, what the CPU will do? The control transfers to the operating system, and from operating system to the disk from disk we are getting the 7th page and place it in the main memory. So this is page fault. Because 7 is not there in the main memory. So this is the main memory. Here 7 is not there. We are getting from the disk. So if the page is not present in the main memory, that we call it as a page fault. So the page fault is indicated with star. Next, the CPU is demanding for the reference string next 0. Okay, 0 is not present in the main memory. So this is also page fault. So next, 1. So 1 is also not present in the main memory, so we are getting from the disk. Okay. So now I want to store the 2. So the CPU is demanding for the 2 in the main memory, but it is not there in the main memory, so obviously it is page fault only, but already the main memory is full. The main memory, whatever it is there, it is full. So what it will do? So it has to replace the page which is not using. So what this concept FIFO will do? First in, first out. So what is the item that is placed in the first? So the first item that we placed in the memory is 7. So the 7 has to be replaced. So the 7 has to be replaced. That is swapped. The 7 is swapped to disk, and from disk the 2 will be placed in the place of 7. So it is just swapped to the disk, and then from disk we are getting the 2. 2, 0, 1. So this is also page fault because 2 is not present in the main memory. So after 2 I have to place the 0. But the demanded page that is already present in the main memory. So no need to bother about it. So this you call it as a hit. If the demanded page is present in the main memory, that you call it as hit. So next, 3. So the CPU is demanding for the 3. So the 3 is not present. So we have to get from the disk. So which page I have to be replaced? The first in, first out. The 7 is first in, first out. So this is already removed. So next is 0. So the 0 has to be sent to disk, and from disk we are getting the 3 value. Okay. So in place of 0 I have to place 3, 1. So this is also page fault because 3 is not present in the main memory. So next I have to place 0. So in which place I have to place 0? I have to replace 1. So the next first in first out is 1. 2, 3, 0. So this is also page fault because 0 is not present in main memory. So next I want to place 4. Okay. So which I have to be replaced? So that I have to replace 2. So 4, 3, 0. So this is also page fault because 4 is not present. Next I have to place 2. Now 3 has to be replaced. 4, 2, 0. So this is also page fault. Next 3. This page has to be replaced. 4, 2, 3. There is also page fault. Next 0. So the first in first out, what is this? 4 is first in. So that has to be replaced. Now place 0, 2, 3. This is also page fault because 0 is not present. Next I want to place 3. But 3 is already present in the demanded page by the CPU 3, that is 3. The 3 is already present in the main memory. So just write 0, 2, 3. So this you call it as hit. So next 1. Which place I have to be replaced? The 2 has to be replaced because 2 is staying in long time. The first in page is 2. 2 has to be replaced. So 0, 1, 3. This is also page fault. So next I have to place 2. Which place has to be replaced? So 0, 1, 3. So the 3 staying in long time. So just replace 3. That is 0, 1, 2. Okay. And the last page. What is it? Last page. The last page that is demanding the CPU is 0. But 0 is already present in the demanded page is already present in the main memory. So just write. So this you call it as hit. And this is page faults. So the star marks is called as a page faults and these are the hits. So we can, by seeing this, we can observe that the number of page hits are, how many page hits are there? 1, 2, 3. Total page hits are 3. How many page faults are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Total 12 page faults are there. Okay, so by seeing this page hit and page faults, we can decide which this FIFO algorithm is suits or not for our program. So actually the page faults can be calculated as, suppose, a hit ratio. If you want to calculate the hit ratio can be calculated by number of hits by total number of references. So this is a formula to calculate the hit ratio. So what is the number of hits? Number of hits are 3. What is the total number of references? Means the pages that we are requesting, the CPU is requesting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Total 15 pages into 100. Okay. And we can also write the page faults also. Sorry. Page fault ratio. Page fault ratio. So this is also calculated by number of page faults, that is the 12. Number of page faults by total number of references, that is the 15 into 100. So this you will get the approximately, you will get the value as 20% and this you will get approximately the value of 80%. So this FIFO algorithm is handling 20% hit ratio and fault ratio is 80%. So this is a poor performance. So hit ratio is 20% and fault ratio is 80% for the FIFO algorithm. So this is how the FIFO page replacement algorithm will work. Thank you.